Today, we'll be talking about integration by trigonometric substitution. There are 3 cases for this one, and now let us start first with case number 1. The square root of a squared minus u squared. Substitute this as u would be equal to a sine of theta. Now, let us start first with this first problem, the integral of 1 minus 4x squared of dx. And so, u here would be equal to 4x squared. And now, square root of 4x squared is 2x. A squared here is 1. Square root of 1 is simply 1. And so that we have our values, let us substitute it into this form. So it would be u here is 2x would be equal to a here is 1 sine of theta. And so x right here would be equal to sine of theta over 2. And so the derivative of sine of theta over 2, you can solve this by quotient rule, but the derivative of this is 1/2 cosine of theta multiplied by d of theta. Now that we have all our values, let us start substituting it. It would be the integral of the square root of 1 minus, let us rewrite this for x squared as 2x squared of dx, which would be the integral of square root of 1 minus 2x value right here would be sine of theta, or sine squared of theta because it is squared, of multiply this by the value of dx, which is 1/2 cosine theta d of theta. And now let us start simplifying this integral. Put 1/2 outside the integral. And you can see here 1 minus sine squared of theta. This would be equal to cosine squared of theta because of its trigonometric identities. Sine squared of theta plus cosine squared of theta is equal to 1. This is the trigonometric identities. And so by putting it in this form, cosine squared of theta would be equal to 1 minus sine squared of theta. Multiply this by cosine of theta d of theta. It would 1/2 the integral of square root of cosine squared is cosine, and multiplying cosine by cosine, this would be equal to cosine squared of theta. Multiply this by d of theta. And now let us integrate cosine squared of theta. So by trigonometric transformation, this would be 1 plus cosine 2 of theta over 2. Simplify this, it would be 1/4 the integral of 1 plus cosine 2 of theta. And now, integrating this, it would be 1/4 multiplied by the integral of 1 d of theta is simply theta plus the integral of cosine 2 theta would be equal to 1/2 sine 2 of theta. And do not forget the constant of integration. Let me just make some space here real quick. Now that we have our answer here, wait, now that I think about it, we can just transform sine 2 of theta as 2 cosine of theta sine of theta would be equal to sine 2 of theta. We will just substitute this in this form. So this would be 1/4 of theta plus 4 times 2 is 8. Multiply this by 2 cosine of theta sine of theta plus c. This 2 and 8 will divide each other, so it would be 1/4. And now, this is yet still not our answer because we have to substitute it back. And so, in order to know what the value of theta, cosine, and sine of theta here, let us use the right triangle method. Let this be the theta. And so, let us base this data on here or by here. So this would be 2x, wait, or you can just simply use this. X would be equal to sine theta over 2. Wait, I made a mistake. This should be just simpler. It would be sine of theta would be equal to 2x 1. And so, sine of theta right here would be equal to 2x over 1. And so, if you still remember the katawa, so here is equal to sine would be equal to opposite over hypotenuse. So, opposite here is 2x and hypotenuse is 1. And so, the adjacent value right here would be equal to square root of 1 minus 2x squared. Or you can just put it as 1 squared minus 2x squared. And now, let us find the value of theta. Theta right here would be equal to arc sine of 2x over 1, but this is simply just 2x. And the cosine value right here would be equal to, based on the katawa, cosine would be equal to adjacent over hypotenuse. And so, cosine right here, cosine of theta, would be equal to adjacent right here would be square root of 1 squared. Wait, let me just rewrite this in a neater form. Would be equal to value of adjacent is 1 squared minus 2x squared over hypotenuse is 1. And now that we have our values right here, let us substitute it. This would be 1/4 theta is arc sine of 2x plus 1/4, and the value of cosine right here is square root of 1 minus 2x squared, and the value of sine of theta is simply 2x. And don't forget to add the constant of integration. And so let us simplify this. This would be 1/4 arc sine of 2x plus, you can see here, value of 2 here and 4 would divide, so this would be 1/2. Let's just move x nearer, so it would be 1/2 of x multiplied by the square root of 1 minus 2x raised to the power of 2 plus c. And now the final answer here would be equal to 1/4 arc sine of 2x plus 1/2 of x multiplied by the square root of 1 minus 4x squared plus c. Let us start with case number 2, wherein the square root of a squared plus u squared, or it can be reversible because it is addition, u squared plus a squared, substitute it as u equal a tangent of theta. Let us start with this problem. The integral of square root of x squared plus 16 over x raised to the power of 4 of dx. Let u squared here be x squared, and so u here is x. A squared right here is 16. Square root of 16 is 4. So let us substitute it on here. It would be x equal 4 tangent of theta. And so derivative of 4 tangent of theta would be 4 secant squared theta d of theta. And so it would be the integral of square root of x here would be 4 tangent theta raised to the power of 2 plus 16 over 4 tangent of theta raised to the power of 4, and multiply this by value of dx, which is 4 secant squared of theta d of theta. And now what you're going to do here next is to simplify it first, or factor sum of it. And so it would be the square root of 4 squared tangent squared of theta plus 16 right here is 4 squared over 4 tangent of theta raised to the power of 4 multiplied by 4 secant squared theta d of theta. In dealing with instances like this, you must find a trigonometric identity here for simplification. So this would be the integral of square root of 4 squared multiplied by tangent squared of theta plus 1. I just factored it over 4 tangent of theta raised to the power of 4 Now we can finally see here a trigonometric identity, which is tan squared of theta plus 1. Now this would be equal to secant squared of theta, because the original identity for this is tangent squared of theta would be equal to secant squared of theta minus 1. This is the original identity. And so this would be the integral of square root of, wait, now that I think about it, you can just square root the 4 squared here. So this would be 4, because square root and its squared would cancel each other out, multiplied by the square root of tan squared of theta plus 1 would be equal to secant squared of theta over, if you see this, 4 here would cancel, so this would be now 3. So this would be 4 cube tangent, wait, this should be only 4 tangent 4 of theta multiplied by secant squared of theta d of theta. Now simplify this. This 4 here would cancel each other out, so this would be 4 squared. This would be the integral of square root of secant squared of theta over 4 squared is 16 tangent 4 of theta. And now put the constant outside the integral, so this would be 1 over 16, the integral of square root of secant is secant over tangent raised to the power 4 of theta, and multiplying secant squared of theta by secant of theta, this would be secant cube of theta d of theta. Now let us simplify this further. This would be 1 over 16, the integral of, by simplifying this, we will put this into their simplest forms. Secant is equal to 1 over cosine, but since this is cube, it would be 1 over cosine cube of theta over tangent is sine, tangent is equal to sine over cosine, so this would be sine 4 of raised to the power 4 of theta over cosine raised to the power of 4 of theta. Now cosine cube and cosine 4, only cosine will survive, so this would be 1 over 16, the integral of cosine of theta over sine raised to the power of 4 of theta d of theta. You can rewrite this integral as 1 over 16, the integral of sine raised to the power of 4 of theta multiplied by cosine of theta d of theta. Now by let us integrate this, but first let us do u substitution. Let u here be sine theta, and so derivative of sine of theta derivative of sine is cosine of theta d of theta. So this would be 1 over 16, the integral of u raised to the power of 4 cosine theta multiplied by d of theta is simply du. So this would be 1 over 16 multiplied by u raised to the power of negative 3 over negative 3 plus constant of integration. Putting u back into its original form, it will be 1 over negative 1 over 48 multiplied by sine raised to the power of negative 3 of theta plus c. And now this would be equal to negative 1 over 48 multiplied by 1 over sine cube of theta plus c. But you can put this as the negative 1 over 48. The inverse function of sine is cosecant. So it would be negative 1 over 48 cosecant cube theta plus c. Now we need to know the value of cosecant cube of theta. And so let us use the right triangle method again. Let this be theta. And so let us take our value based on this. X equal 4 tangent of theta. Tangent of theta right here would be equal to x over 4. And so based on the hypotenuse, TOA, which is tangent, would be equal to opposite over adjacent. And so opposite right here would be x, adjacent is 4. And so the hypotenuse is equal to x squared plus 4 squared, because this is a squared plus b squared equals c squared, or to get the c here, it would be square root of a squared plus b squared, which is this. Just in case you forgot about the Pythagorean theorem. And now that we have all our data, let us find cosecant. If sine here is equal to opposite over hypotenuse, the inverse of this, which is cosecant, is hypotenuse over opposite. And so taking the hypotenuse here, it would be square root of x squared plus 4 squared over the opposite, which is x. Now that we have our data, let us start substituting it now. So this would be negative 1 over 48. Cosecant here would be equal to square root of x squared plus 4 squared over x plus c. And now the final answer here would be equal to negative, wait, don't forget the cube here, negative x squared plus 4 squared here is 16, and square root of x squared plus 16 raised to the power of 3. This would be equal to x squared plus 16 raised to the power of 3/2 over multiply 48, multiply this by x, so it would be 48 x raised to the power of 3, because don't forget this is distributed as like that. And don't forget to add the constant of integration. And now let this be your final answer. Let's start with case number 3. The square root of u squared minus a squared, it would be u equal a secant of theta. Let us start now with our example regarding case 3. The integral of dx over the square root of x squared minus 5 raised to the power of 3. U squared here is x squared, u is x, a squared right here is 5, square root of 5, we will just write it as square root of 5. Now, substitute it in here, it would be x equal square root of 5 secant of theta. Derivative of square root of 5 secant theta is square root of 5. Derivative of secant theta is secant theta tangent theta multiplied by d of theta. Let us now start substituting it. It would be the integral of dx is square root of 5 secant theta tangent of theta d of theta over square root of x squared, which is square root of 5 secant theta squared minus 5. Now, let us first simplify this bottom part. Square root of 5 secant theta is squared. Square root of 5 squared is simply 5, and secant squared is secant squared of theta. So let us rewrite this. It would be 5 secant squared of theta minus 5. Now simplify this once again. Let us factor 5 here. So this would be equal to 5 multiplied by secant squared of theta minus 1. Don't forget to add the cube. And so, this is another trigonometric identity. Secant squared of theta minus 1. This is equal to tangent squared of theta. So this would be 5 tangent squared of theta. Now let us split this apart. This would be equal to square root of 5 multiplied by square root of tangent squared of theta. But the square here and square root would cancel each other out. So this would simply be square root of 5 tangent theta. So let us simplify this once again. Distribute the cube in here. So this would be like this. It would be square root of 5 raised to the power of 3 multiplied by tangent raised to the power of 3 of theta. Square root of 5 and 1 square root of 5 here would cancel. And so, this would be equal to square root of 5 squared. And we know that square root will cancel each other out and the square. So this is basically just 5. So put 5 there. And cancel 1 tangent here. So this would be 2. And now the simplified form here would be equal to 1/5 the integral of secant theta d of theta over tangent squared of theta. And now, in simplifying this, we will put these trigonometric identities into their simplest form. So this would be equal to, the simple form of secant is equal to 1 over cosine of theta over tangent here is sine sine squared of theta, because this is in tangent squared, over cosine squared of theta. Cosine here would cancel. And so your answer here would be 1/5 the integral of cosine theta over sine squared of theta d of theta. Put sine above, so this would be 1/5 the integral of sine raised to the power of -2 of theta cosine of theta d of theta. And now, let u there be sine of theta. And so, derivative of sine is cosine theta d of theta. So this would be 1/5 the integral of u raised to the power of -2 cosine of theta d of theta. This is this, so this would be equal to du. The integral of u raised to the power of -2, it would be u raised to the power of -1 over -1 plus the constant of integration. Substitute u back into its original form, you will have -1/5 multiplied by u here. U there earlier is sine raised to the power of -1 of theta plus c. You can simplify this by putting sine raised to the power of -1 into its inverse form. So this would be -1/5. The inverse of sine is cosecant of theta plus c. And now that we have this answer, we need to find the value of cosecant. So we will use the right triangle method once again. And using this data. And so, x would be equal to square root of 5 secant of theta. So secant of theta right here would be equal to x over 5. The inverse of secant is cosine. So in the SOHCAHTOA factor, cosine right here is equal to adjacent over hypotenuse. And so since this secant is inverse of cosine, secant right here would be equal to hypotenuse over adjacent. And so hypotenuse here is x and adjacent is square root of 5. Now, in case you don't know how to calculate this, let this be A, this be B, and C the hypotenuse. And so based on the Pythagorean theorem, A squared plus B squared is equal to C squared. And so what we are looking for here is the value of B. So B squared here is C squared minus A squared. And so the square root of this, or just B, is equal to the square root of C squared minus A squared. Or let B here now would be equal to C squared here is x minus A squared right here, since it is square root of 5. So this would be just simply 5. So this is the value that we are looking for as B. So this is equal to square root of x squared minus 5. And so what we are looking for here is the value of cosecant. Keep in mind that sine here is equal to opposite over hypotenuse. And so since the inverse of sine is cosecant, this would be hypotenuse over opposite, or the hypotenuse here is x, and the opposite here is square root of x squared minus 5. Keep in mind, in order to know what the opposite is, base this on the theta value. This is its opposite side. Know that the hypotenuse is the longest length and adjacent is just its beside. So that we have our cosecant value. This would be the final answer. It would be negative x over 5 multiplied by the square root of x squared minus 5 plus the constant of integration.